Here we have AP calculus AB problem. Okay, let's go to the information. For questions 1 to 3, consider the function f prime of x shown at the right with domain all real numbers. Okay, here we have the graph of the first derivative of the function f of x. So that is we have the graph of f prime of x. Always you have to remember it's not a graph of f of x, it's a graph we have for f prime of x. Okay, the first question is determine the intervals in which f of x is concave down. Justify. Okay, so from the graph of the first derivative, if I want to find the point at where, the interval at where the graph of f of x is concave downward, so I have to find the interval in the given graph of first derivative where f prime of x is decreasing. So let's say this is point x is equal to 0 and here we have x equals to 2 because this point is corresponding to the value 2 on x-axis. From x is equal to 0 to 2, the graph of f prime of x is decreasing when you look at the graph from left to right side. And particularly when you consider this decreasing interval from x equal to 0 to x equals to 2, consider another value for x, it is x equal to 1. So here from x equals to 0 to 1, the sign of f prime of x is positive. So f prime of x means this is nothing but y. So the y coordinate is positive over here from x is equal to 0 to 1 because we have the graph above the x-axis. Because if you consider any point above the x-axis, the y coordinate will be 0. And from x equals to 1 to 2, if you consider any point on the graph of f prime of x, the y coordinate is negative. That is f prime of x is negative. So let me write the stuff over here. When x is equal to 0, from x equals to 0 to x equals to 1, the first derivative f prime of x is positive. That is the y coordinate on the graph of f prime of x is positive. From x equals to 1 to x is equal to 2. So f prime of x is negative. So because the y coordinate over here is negative because it's below the x-axis. So that is f prime of x usually represents the slope of the graph of the given function f of x. So since f prime of x is greater than 0, the slope is positive. And f prime of x is negative means the slope is negative. So whenever the slope is positive, then the curve must be rising from left side to right side. If the slope is negative, then the curve must be falling. So from x is equal to 0 to x is equal to 1, the slope is positive. So the graph of the original function f of x must be rising, and from x equals to 1 to x equals to 2, it has to be falling because the slope is negative. So here we have x equals to 0, and at this point we have x equals to 1. At this point we have x equals to 2. So from 0 to 1, the slope is positive. That is the graph of f prime of x is getting positive y coordinate. So and from x equals to 1 to x equals to 2, the graph is below the x-axis. The y coordinate of this graph f prime of x is negative. So it's the slope is negative. So it's falling. So clearly it's concave down. So from x equals to 0 to 2, the graph of the function f of x is concave down. So in interval notation, we can write 0, 2. So the interval in which the graph of f of x is concave down is 0, 2. Okay, now let me erase other stuff and answer the second question. Okay, the second question is identify the x values of local extrema on f and identify the type. Okay, here we have to find, we have to identify the values of x for which we have local extrema, that is local maximum or local minimum for the graph of the function f of x, and also we have to identify the type. Identify the type means local maximum or local minimum. Okay, so for that what we have to do is again we have to use the graph of f prime of x. So to find the local extrema of f, I have to check where this f prime of x changes its sign from positive to negative or negative to positive. The particular values of x. Now let me consider this particular value of x, that is x equals to -1. So when I consider the stuff on the left side of -1, so the graph of f prime of x is below the x-axis. That means this f prime of x is negative on the left side of x equals to -1. So when I goes to the right side of x equals to -1, so we have the graph of f prime of x above the x-axis. So the y coordinate is positive. That means this is positive. So f prime of x changes its sign from negative to positive at x equals to 1. So like since f prime of x is negative on the left side of x equals to -1, so we must have a falling curve for the graph of f. So let me sketch the graph over here at x equals to -1. Okay, so on the left side of x equals to -1, so since f prime of x is negative, so we have a falling curve over here. On the right side of x equals to -1, we have the graph of f prime of x above the x-axis, that is y coordinate is positive. Y coordinate is positive means f prime of x is positive, then we must have a rising curve over here. So look at here. So clearly this is a local extrema, and specifically it's a minimum. So at x equals to -1, we have a local extrema. So the type of extrema is local minimum. So let me write the stuff over here. At x equals to -1, we have a local minimum. Let me finish writing. Okay, now let's consider another values of x for which f prime of x changes its sign. Okay, so now let's consider this particular value of x at x equals to 1. So on the left side of x equals to 1, we have the graph of f prime of x above the x-axis. So this is positive. On the right side of x equals to 1, so we have the graph of this f prime of x below the x-axis, so it's negative. So on the left side of, let me sketch the graph over here. Okay, here this is a point of x equals to 1. On the right side of x equals to 1, the graph of f prime of x is above the x-axis, so the slope is positive. Slope is positive means it has to be rising. And on the right side of x equals to 1, we have the graph of f prime of x below the x-axis, so this f prime of x is negative. So since the slope is negative, this curve has to be falling. So clearly this is a maximum point at x equals to 1. We have a local maximum. Let me write the stuff over here. So local maximum. Okay, now let's consider another value of x where f prime of x changes its sign. So clearly it's x equals to 3. So on the left side of x equals to -3, like look at here, sorry, left side of x equals to 3, we have the graph of f prime of x below the x-axis. So this is negative, that means the slope is negative. Then we must have falling curve on the left side of x equals to 3. On the right side of x equals to 3, we have the graph of f prime of x above the x-axis, so it's positive. So that is when f prime of x is positive, the slope is positive, we must have rising curve. So let me write the stuff over here like this. So here we have the point x equals to 3. On the left side of x equals to 3, the slope, we have the graph of f prime of x below the x-axis. So it is negative. Since slope is negative, we have a falling curve over here. On the right side of x equals to 3, we have the graph of f prime of x above the x-axis. So the slope is positive. This f prime of x is positive. Then we have a rising curve. Again, it's a local minimum. So at x equals to 3, we have a local minimum. Let me write the stuff over here. Okay, now we have finished answering question 2. Okay, now let me erase some stuff over here and answer question number 3. Okay, now let's answer question number 3. Identify the x values of all points of inflection on f. Justify. That is, we have to find the values of x at where we have points of inflection for the graph of f of x. Okay, for that I am going to consider the results of question number 2. That is x equals to -1, we have local minimum. At x equals to 1, we have local maximum. At x equals to 3, we have local minimum. Okay, so here we have local minimum at x equals to -1. Let me sketch a rough graph for f of x over here. Let me finish sketching over here. Okay, at x equals to -1, we have local minimum. At x equals to +1, we have a local maximum over here. At x equals to 3, again we have local minimum. Okay, clearly, so here it's concave upward, and here it's concave downward. Here it's concave upward. So between x equals to -1 and x equals to +1, the curve changes from concave upward to concave downward. Between x equals to 1 and x equals to 3, again the curve changes from concave downward to concave upward. So there are 2 points of inflection. We have one point of inflection between x equals to -1 to +1. The other point of inflection is going to be between x equals to 1 to +3. So how do you have to find the values of x exactly over here and here? Okay, now let's find the first value of x at where the curve changes from concave upward to concave downward. So for that, we have to consider the graph of the first derivative f prime of x. Here we have to identify the values of x at where f prime of x changes from increasing to decreasing or decreasing to increasing. So clearly, approximately at x equals to 0, the graph of f prime of x changes from increasing to decreasing. So this is a point of inflection. So between x equals to -1 and x equals to 1, at x equals to 0, the curve changes from concave upward to concave downward. So the one point of inflection is x equals to 0. Okay, now let's identify the other value of x where f prime of x, the graph of f prime of x changes from decreasing to increasing. That's clearly at x equals to 2. So at this value, the curve changes from decreasing to increasing. So this is another point of inflection, that is at x equals to 2. Between x equals to 1 and x equals to 3, at x equals to 2, the curve exactly changes from concave downward to concave upward. So this is another point of inflection. So there are 2 values of x at where the curve has points of inflection. One is x equals to 0 and the other one is x equals to 2.